Hello everyone! In this video, we would like to share about lipid analysis using related techniques obtained from established methods in the chemical analysis of food. Let's start our sharing with introduction to lipid analysis. In foods, lipid has a significant role. We need lipids in our diets because they are a source of energy. In addition to being a necessary nutrient, lipids have an impact on the flavor, mouthfeel, appearance, and texture of food. But consuming too much lipid can be harmful to our health. We would first discuss what is meant by lipid. Lipid is a constituent that is soluble in organic solvents like hexane or chloroform. But polar solvents like water do not dissolve them. Lipid exist as free fatty acid, phospholipids, sterols, monoacylglycerol, diacylglycerol, triacylglycerol, waxes, and fat-soluble vitamins.
So now we're gonna move to principles involved for lipid analysis method. The first method for lipid analysis is high-performance liquid chromatography, which is known as HPLC. So what is the basic principle of HPLC? The basic principle is it separates a sample into its constituent parts based on the relative affinities of distinct molecules for the mobile phase and the stationary phase used in the separation. The second method for lipid analysis is gas chromatography, which is known as TC. So, the basic principle of TC is it involves separation technique based on the principle of absorption of gases or vapors of a liquid by an absorbent.
Next, let's take a look at the advantages of gas chromatography. The major advantage of gas chromatography it is high in sensitivity, resolution, and separation ability. This allows it to separate a wide range of volatile compounds. Due to its high efficacy, gas chromatography can analyze a sample much faster than other chromatographic techniques. It is also accurate in quantitation, as usually sharp reproducible peaks are obtained. It also comes with a variety of detectors and injectors that can be used for various pharmaceutical as well as other applications. The disadvantages of gas chromatography it is that it is limited to only volatile and thermally stable compounds. The detectors which are used in gas chromatography are destructive, except for mass spectrometer. It is also impossible to recover individual sample components by using gas chromatography. In gas chromatography, you can modify the temperature of the column and oven, but you cannot change the mobile phase as it has a constant flow of carrier gas such as helium and nitrogen.
The advantage of HPLC is exceptionally fast and efficient when compared to other chromatographic methods such as DLC. It forces a liquid solvent through a solid absorbent material using a pump rather than gravity, with various chemical components spurting out as they pass at different speeds. The procedure takes around 10 to 30 minutes to finish and produce great resolution. It is precise and very repeatable. Basic HPLC runs may be conducted with little training because it is mainly automated. Next, it is also can be upgraded to mass spectrometry, as this combination is the most frequently used techniques for analyzing secondary metabolites. HPLC allows powerful and rapid separation, while mass spectrometry has immediate plus a highly sensitive detection. One of the disadvantages of HPLC is it is an expensive method, as it requires countless costly organics and a forced supply. This is because the solvents used in HPLC are more expensive than buying gas containers, and a pressure pump is needed to push the mobile phase through the column in liquid chromatography, which adds to the cost of equipment. Other than that, it is quite complicated and difficult to beginner, as is needed a highly skilled technician to monitor the column of specific protein and its solution at all times to ensure the process runs smoothly. Last but not least, HPLC lacks of universal detector, as it can only detect chromophoric compound.